Hey guys, this is Einar. Welcome to your ninth tutorial in Basic Statistics in Excel. I hope you're really psyched for this tutorial because now we're finally getting started with statistics, which actually is a subject for this course. And the first thing we're going to talk about is a measure of centrality, which is called the median. Now the median gives us the value of the middlemost observation in our data set. So we count our observations, we find the middlemost value observation, and we calculate the value of this observation. Now the problem is, because we've divided our data set into classes, we can't give the median middlemost value an exact number because, well, there's no number called 253 to 289. And besides, if we gave, for example, the average of these numbers, it wouldn't be quite correct because the median isn't the middlemost value of the observations in this class. In fact, it's going to be dependent on the weight of observations in this area and the weight of observations in this area. So we need to calculate this using this formula, which may look complicated, but relax. What we're going to do is we're going to find all of these different parts and just calculate it. If you want to know more theory about the median, there's a tutorial before this one, a theoretical tutorial that I've added to the list that you can check out. So I'm just going to calculate this for now. The first part is n divided by 2, so we'll get started and calculate that. I write sum. I sum up our frequencies and I divide them by 2. We get 7.5. You can just ignore this error. 7.5, okay. How do we know which class this 7.5 is located in? Well, we have a small frequency table, so maybe we could do it anyway, but sometimes you have really large numbers in here and it can be actually kind of difficult to tell. So what we do is we're going to calculate accumulated frequencies. In the first cell, the accumulated frequencies is the same as the number of observations in the first class, so that's just simple enough. But in the next cell, we want these observations plus these observations because we want the accumulated frequencies up to this point. So we go the frequencies we have so far plus the frequencies we're adding in this new class, and we get 4. Now we can pull this down and we see we get 15 here in the last class, which is the same as our total, so we've done this correctly. Excellent. So we're looking for 7.5 in order to find this x0 down here. We get 2, we get 4, and then 10 here. So that means that the 7.5th observation in material must be located somewhere in this class. So that's excellent. We now have the class we're interested in. X0 was the lower class limit for the class where the median is located, so we need to find the lower class limit. You might think this is 253, but no, it is not. Why is this? Well, the lower class limit is actually going to be equal to 252.5, and I'm going to tell you why. While our observations are discrete values, there's no 2.5th observation or 3.1st observations because they are people or just events. We're locating something, and there's no half event, at least not at the level we're working. So we're always rounding these numbers in theory to integers. In Excel, if you write the number 2.3, for example, it'll round it down to 2. If you write the value 2.7, it'll round it up to 3. So that's what we're doing. And in this case, the median actually it's not a real observation. It's a theoretical observation. It's a point of center in our data set. So it's going to be it can actually be 7.5. So we need to account for this when we're calculating our median in this formula. So we're actually going to have to change these integers to the float numbers, like with decimal points. So that's why we're using this version. So 252.5 is the lower class limit for this class. N0 is the number of observations up to the lower median class limit. So we check that out. And we can actually look at our accumulated frequency. We got 2, and there's 4 observations up to the class we're interested in. So we write there 4. N1 is equal to the number of observations up to the upper median class limit. Now that's the accumulated frequency up to and including the class we're interested in, which in this case is going to be 10. Next, we need W, which is class width. Now, the class width, be careful here. As we said, the limits are in between these classes. So the upper class limit for our class is actually going to be 289.5. So we take 289.5 minus our lower class limit, and we get a class width of 37. Excellent. We are now ready to calculate our median because we have all the different parts for our formula. And as I said before, if you want to know more, check out the theoretical tutorial. we go equal to, you can see the formula here and you know, check it out while I'm working this out. We need x0 plus 2 parentheses, n divided by 2 minus n0, another parenthesis, and we divide, and another parenthesis, and we want n1 minus n0, so we go n1 minus n0, another parenthesis, and we multiply all of this by our class width. What is happening here? Why are we using all these parentheses here? Well, Excel calculates operators by the same rules as in regular maths. It will actually divide before it subtracts. It will multiply before it adds, etc. So we need to tell Excel explicitly in what order to do stuff, because otherwise Excel would actually divide H7 by H8 before conducting these subtractions. In other words, it would divide N0 by N1 before conducting this subtraction and this subtraction. So we're telling Excel, hey, do it in the order we want to do it, so don't screw up our formulas. So now we hit enter and we get a median of 274, which is located here in the in our median class, so to speak. So that's how you calculate the median. It's a very exciting measure. We're going to talk more about the percentiles and quartiles that are related to this in later tutorials. For now, I just hope to see you in tutorial number 10 and have a great day.